Okay, now we're going to look at sequences where the gaps between each successive term changes. Okay, so in this case here, simple case here, says find the next term in the sequence. Okay, so we're just interested in what goes here. If you look at the gap here, okay, I'll write these numbers out slightly bigger maybe, the gaps between them. There's more gaps so we can write. Now if you notice here, of course we're adding on 1, aren't we? Okay, and then if you notice here, 9 to 13, we're adding on 4. Okay, and then 13 to 22, look at that gap there, we're adding on 9, aren't we? Yeah, and then 22 to 38, if you notice there, we're actually adding on 16. Okay, so the gaps change quite dramatically, and you might be thinking, well, there's no sort of pattern here. But if you know your numbers well, you might realize that these are actually special numbers. Okay, if you think about it, these are the square numbers, aren't they? That's 1 squared, 2 squared is 4, 3 squared is 9, 4 squared is 16. The next one, of course, because it's going up, that's 4 squared. The next one will be 5 squared, which is 25. So we need to add on 25. 38 at 25 is 63. Okay. Question 2, write down the next 2 numbers in this sequence. Well, if we look here, again I'll write them out. There's more room. If we look at that gap there, I think here we're taking away 11, aren't we? Yeah. And then here, if we look at that, we're actually taking away 9. Here we're taking away 7. Here we're taking away 5. So can you see what's going on here? We're taking away a number each time, but the amount we're taking away is reducing by 2. So the next subtraction will, of course, we'll be taking away 3 then, so we get 63. Okay, so 63 can go there. And then, of course, the next one we're going to be taking away 1. So we get 62. Can go there. Okay. Write down the first 5 terms of the sequence n squared. So back to our square numbers, okay? N squared, of course, well, if we start off, we want the first 5 terms, so we'll start off with the first term, which of course will be 1 squared. And 1 squared is just 1 times 1, which is 1. Okay? Then we go for the second term, so 2 squared. Okay, so I've done 1 squared, now I'm going to do 2 squared. 2 squared is just 2 times 2, which is 4. 3 squared, okay, will be the next. 3 squared is 3 times 3, which is 9. 4 squared is 16. And then 5 squared is 25. Okay, now this is a sequence. Okay, it's involving the square numbers. What I want you to notice though is that the gaps, notice the gaps, they're not the same, aren't they? The gap there is 3, the gap there is 5, the gap there is 7, the gap there is 9. Okay, so sequences involving square numbers will have different gaps. Okay, question 4, it says the nth term of a sequence is n squared plus 5. List the first 3 terms of this sequence. So first term will be 1, obviously 1 squared, when we set n to equal 1. So 1 squared plus 5, which equals to 1 squared is 1, plus 5 is 6. Then if you set n to equal 2, 2 squared plus 5, plus 4 plus 5 is 9. And then n equals 3, so 3 squared plus 5, 3 squared is 9, plus 5 is 14. So you've got your first 3 terms here, and notice again the gap is different. The gap there is 3, the gap there is 5. What you should also notice as well, which is interesting, if you think about the square numbers, look at the first 3 square numbers, 1 squared, 2 squared, 3 squared, compare that with what we've got here. Okay, compare them. So you've got 1 squared is 1, 2 squared is 4, 3 squared is 9. Now here we've got n squared plus 5. If you think about it, these are the square numbers plus 5. Okay, so that's like 1 plus 5 gives me 6. If I add 5 onto that, it gives me 9. If I add 5 onto that, it gives me 14. Okay, so I get that sequence here. Number 5, n squared minus 2. Okay, so 1 squared minus 2, they're asking for the first 3 terms again. So 1 squared is 1, take away 2 is minus 1. 2 squared, take away 2 is 2. 3 squared is 9, take away 2 is 7. Again, right, think about your square numbers. 1, 4, 9, okay? I can get that sequence from my square numbers, okay? So take away 2, I get minus 1 from that. I get 2 there, I get 7 there. Okay, now this is the type of question they'll ask in an exam. And it says, write down the nth term of the sequence 5, 8, 13, 20, 29. So write them out big again. If you notice, the gap is different. The gap there is 3. The gap there is 5. The gap there is 7. The gap there is 9. So when the gaps are different and they want the nth term, we simply need to think about square numbers. I'm going to write them down. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. Let's compare the square numbers with the sequence they've given us here. Okay, hopefully you see a pattern. Look at the way I've lined them up, obviously. Can you see? All you've got to do to get from the square numbers to this is just to add on 4, isn't it? If you add on 4 to the square numbers here, add on 4 to 1, you get 5, add on 4 here, you get 8, add on 4 here, you get 13, and so on. So my answer will be n squared, the square numbers, add on 4. Okay, again, notice here now, right? The gap is different. If you look at the gap, so let's write down our square numbers. Okay, our square numbers. Compare them. This is n squared. What have you got to do to this to get to that? It's just take away 1, isn't it? There's my answer. Do the same here. If you notice, the gap is different. So we write down our square numbers. Now what have you got to do to 1 to get to 7? You've got to add on 6, haven't you? Again, it works here. Add on 6, add on 6. So this will be n squared plus 6. Okay? Now here you might think this is a straightforward nth term. Okay? Where you write something n, we're looking at the difference. But if you look at the difference, okay? Again, I'll write these out so there's more gap. If you look at the difference changes. The difference there is 11. Difference there is 9. Difference there is 7. It changes. So let's write down my square numbers. 1, 4, 9, 16, 25, 36. Let's compare them. If we've got n squared, what do I need to do to the square numbers to get to here? Well, if you look at this, it's just take away 10, isn't it? Take away 10, it works. Take away 10, it works. Take away 10, it works. It works for all of them. So n squared minus 10. Okay, last page. Again, back to the sort of picture idea, patterns. You can sometimes get this. Okay, obviously this pattern here, we've got squares. We've got squares. If we change this into numbers, you've got 1 square there. You've got 4 squares here. Count them, you've got 9 squares there. 16 squares there. Your square numbers. Okay, so find an expression in pattern n. This is just going to be n squared. Okay, because it produces the square numbers, and of course we've got the shapes in terms of square. Last one. Notice this is very similar to what we've just seen. Okay, up here we had the squares. Notice here we've got squares, especially these ones here. We've got squares. We seem to have an extra one added on. Can you see that there? We've got a square with that one added on. we've got a square with that added on, a square with that added on, and actually here we've got a square with that added on. So in this case, this would be n squared plus 1. Okay, n squared plus 1 added on, and I can prove that to you by just looking at the sequence we've got here. We've got 2 little squares here, count them, we've got 5 squares here, count them, you've got 10 squares there, count them, you've got 17 squares. This is just n squared plus 1, because your square numbers are 1, 4, 9, these are your square numbers. 16, so if you notice, you're just adding on 1, so that's my nth term there.